why is 1 minus 0 factorial equal to 0? Well, before we answer this question, let's sort out a few things. What exactly is factorial? Supposing we have a number n, then n factorial written like that is equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 all the way until we get to 3 times 2 times 1. That's n factorial. For example, if we are given 2 factorial, this is equal to 2, our n is equal to 2, multiplied by 2 minus 1, which is 1, which of course is just 2. Another example, 3 factorial. This is equal to 3, which is our n, multiplied by 3 minus 1, which is 2, multiplied again by 3 minus 2, which is 1, which gives us 3 times 2, which is a 6. Lastly, 4 factorial. This is equal to, our n is 4, so that's 4 multiplied by 4 minus 1, which is 3, multiplied by 4 minus 2, which is 2, multiplied by 4 minus 1. Sorry, let's do it again. Our n is 4, 4 minus 1, 3, 4 minus 2, 2, and 4 minus 3, which is 1. I almost got it wrong there, didn't I? So that gives us a 4 times 3 times 2 times 1, which is equal to 24. So that's our factorial there. Now, the next thing that we want to do is to define a special function which is called a gamma function. So let's define a gamma function. Which is a function of n. This here is the capital letter gamma. So gamma function, a gamma of n, is equal to, it's defined as the integral from 0 up to infinity of x to the power n minus 1 multiplied by e to the power minus x with respect to x. So let's go through it again. This is the Greek letter gamma. So gamma of n, which is a function, is defined as the integral from 0 up to infinity of the product of x to the power n minus 1 e to the power minus x dx. This, of course, is the exponential function, and the 0 and infinity are the limits of integration. Right. The next thing that we want to do is to show that gamma of 1 is equal to 1. In other words, if we substitute 1 for n here, we should get 1. Let's try that in C. So gamma of 1 is equal to, now we're going to put a 1 there, the integral from 0 up to infinity of x to the power 1 minus 1, which is 0, and x to the power 0 is 1. So we are left with e to the power minus x dx. So we have e to the power minus x dx. And this, of course, integrates to minus 1 over e to the power x evaluated from 0 up to infinity, which, of course, is just 1. Because remember, when we put x is equal to infinity, this term vanishes. And when we put x is equal to 1, to 0, any number to the power 0 is equal to 1. And that gives us a positive 1 there. So we have proved that gamma of 1 is equal to 1. Let me just put this result somewhere in a different color. So gamma of 1 is equal to 1. This is an important result. we shall need it a little later on. Okay, now we have defined that. Let's find out what gamma of n plus 1 is equal to. So again, gamma of n plus 1 is equal to, we are now replacing our n with n plus 1. So again, we integrate from 0 up to infinity of x to the power n minus 1 plus 1, which is just x to the power n. X to the power n multiplied by e to the power minus x dx. Here we need to use integration by parts to evaluate this integral. So let u equal to x to the power n, and our du dx will of course be equal to n x to the power n minus 1. Let also our dv dx equal to e to the power minus x, so that our v is equal to minus e to the power minus x. Now, integration by parts says the integral of u dv dx is equal to uv minus the integral of v du dx, which of course gives us our u. We said it's x to the power n. Our v is that, so that becomes minus x to the power n e to the power minus x. Remember, we have a negative sign here. That's what I've just put here. Evaluated, of course, from 0 up to infinity, minus our v, the integral, from 0 up to infinity. Our v is minus e to the power x, and our du dx is equal to that. So that gives us minus n x to the power n minus 1 e to the power minus x dx. Again, this negative sign is accounted for by this thing here. So let's see now. I'm going to run out of space down here, so let me cross over to that side. So what we have here, let's evaluate this one, is from 0 up to infinity. When x is equal to infinity, the term e to the power minus x vanishes. When x is equal to 0, the term x to the power n vanishes. So this term here is just 0. So we are left with what is here. So let's remember we have two negative signs. So when we bring it out, that becomes a plus. And let's also take the n out of this. So that means that, remember, this is our gamma of n plus 1 is now equal to n integral of from 0 up to infinity of x to the power n minus 1 e to the power minus x dx. But wait a minute, when you look at this here, this part here, it is actually the definition of gamma of n. That one there. So what it means is that gamma of n plus 1 is simply n multiplied by gamma of n. So this is equal to n multiplied by gamma of n. So we've proved that our gamma of n plus 1 is equal to n multiplied by gamma of n. But now, this also implies that if gamma of n plus 1 is equal to n multiplied by gamma of n, then gamma of n is equal to n minus 1 multiplied by gamma of n minus 1. So let's write it here. So gamma of n itself can be written as n minus 1 multiplied by gamma of n minus 1. Similarly, gamma of n minus 1 is equal to n minus 2 multiplied by gamma of n minus 2. Again, gamma of n minus 2 itself is equal to n minus 3 gamma of n minus 3, and so on. So this goes all the way down until we get to gamma of 1. So we can write gamma of n plus 1 is equal to n bracket gamma of multiplied by gamma of n, which is equal to that. So it's equal to n minus 1 multiplied by gamma of n minus 1. But gamma of n minus 1 is that one there, which is n minus 2 multiplied by gamma of n minus 2. But gamma of n minus 2 is equal to n minus 3 multiplied by gamma of n minus 3. Gamma of n. So again, gamma of n minus 3 will give us, let me write it here, multiplied by gamma of n minus 4. And it goes all the way until we get to gamma of 1. Let me just go through this to correct what almost went wrong there. We are saying gamma of n plus 1 is equal to n gamma of n. So if that is so, that means gamma of n is equal to n minus 1 gamma of n minus 1. But it also means gamma of n minus 1 can be written in terms of gamma of n minus 2. And gamma of n minus 2 can be written in terms of gamma of n minus 3. And gamma of n minus 3 can be written in terms of gamma of n minus 4, etc., etc., until we get to the last term, which will simply be gamma of 1. So, now, but what is gamma of 1? We have just found out here it is equal to 1. So we can write again here our gamma of n plus 1 is equal to n minus 1, n minus 2, all the way until we get to 3 times 2 times 1, which is our gamma of 1 there. But what is this here? This is equal to the definition of n factorial. Because look here, our n factorial is n times that, all the way until we get to 1. So gamma of n plus 1 is equal to n factorial. So we can write it there as n factorial. So let's write it neatly and say gamma of n plus 1 is equal to n factorial. But wait a minute. Let's replace our n on both sides with 0. That gives us gamma of 0 plus 1, which is 1, is equal to 0 factorial. But what is gamma of 1? It is equal to 1. So we can write this as 1. So we have established that 0 factorial is equal to 1.